So the filoviruses are negative sense strand RNA viruses. They are enveloped. They used to be grouped in with the rhabdoviruses, the one that causes rabies. But more genetic analysis has determined that they are a little bit more distantly related and are their own group. They infect lots of different kinds of cells. And so that's why we see kind of a broad range of effects when we have patients that are infected with one of these viruses. So what we tend to see at first is flu-like symptoms, about 7 to 9 days after exposure. So you have headache, fever, fatigue, muscle soreness. About day 10, high fever, vomiting, and that vomiting is usually vomiting blood. And what they call passive behavior, meaning there's some sort of neurological complication. By day 11, patients will experience significant bruising. They'll have brain damage because of bleeding in the brain. And they will be bleeding from pretty much every opening they have in the body. Eyes, nose, mouth, anus, vagina, blood. By day 12, you would experience loss of consciousness, seizures, massive internal bleeding, and death. We can see a lot of tissue necrosis in the liver, the spleen, the lymph nodes, the lungs. This is a really, really dangerous type of infection in primates, okay? It causes lysis of the cells lining the endothelial cells, right, lining the vessels, so you get the vascular leakage. That's what causes the internal hemorrhaging and the bleeding. And prior to the most recent big outbreak, and in the absence of treatment, of which there isn't a ton, but there are some, about a 90% mortality. So this is one of those viruses that kind of burns through the host. And, you know, you can think about that kind of evolutionarily as a strategy, right? Because of course, every fluid that is coming out of that patient, the vomit, the blood, right, is full of virus. So if your evolutionary strategy is basically get in, get out, and see who else you can infect, you know, it does that pretty well. But the problem is it does it so aggressively, so quickly, and so noticeably that everybody else is like, ooh. You know, if somebody's bleeding out their eyeballs, you're going to take a lot of precautions when you're dealing with that patient. And the precautions don't always work, but you are going to take precautions. More than you would if somebody just came in and was like, okay. It's a pretty dramatic disease. So there are two major filoviruses that we talk about that infect people. The first is called Marburg. It was named after the laboratory facility where it was first identified. And it was found in Germany and Yugoslavia. Of course, we don't have Yugoslavia anymore, but that's like, you know, Serbia, Bosnia, Croatia, kind of in that area, in Eastern Europe. In 1967, it was in imported primates. First had it and gave it to the laboratory personnel that worked there. So Marburg is the city where the lab was. The Ebola virus is the other filovirus that most of us have probably heard of. It is named after the Ebola River, which was at one point in Zaire. I believe now the area is called the Democratic Republic of Congo. So, I mean, the river is still called the Ebola River, but the country is no longer called Zaire. There are 5 known strains of the Ebola virus. 4 of them kill people. The 5th can infect people, but it's a far more mild infection. Both Marburg and Ebola really quickly will move through susceptible populations. But what some studies have found, which is kind of interesting, is that in areas where Ebola and Marburg tend to emerge, which generally is like, sub-Saharan Africa, Congo, right, formerly Zaire, those areas, upwards of 10% of the population has antibodies against these viruses, indicating that at some point there have been subclinical infections that have gone through the population. And we say subclinical because, again, if you had a moment in your life where you were bleeding from every part of your body, and then later some doctor comes with, hey, have you ever had Ebola? Yeah, I remember that time I was bleeding out of every part of my body. So these are people who have antibodies but never experienced disease. Or maybe they had flu-like symptoms, right? They didn't experience the severe disease that we see in a lot of Ebola and Marburg patients. So primates get a bad rap. If you've seen the movie Outbreak, it's an old one, right? Dustin Hoffman, Cuba Gooding Jr., they're in the army. There's a monkey that escapes in some town in Northern California and gives everybody fictional Ebola and everybody dies. It's normally actually fruit bats that are thought to be the host of the virus. So bats are really interesting. If you remember, bats are where we think a lot of viruses come from. And, again, bats are interesting. Bat physiology is really interesting. Bats have a really robust immune system. The stress that they put on their bodies by flying causes a lot of damage to their muscles. So their immune system has to be really efficient to clean up any damaged cells and to keep them functional because they have to fly, right? They don't have extra wings. Their arms are wings. That's how they fly. That's how they get food. That's how they do everything, is they have to fly. So they have to have a really robust immune system. And so it's thought that their immune system actually keeps a lot of these infections in check because their immune system is so good. So they, host rabies and don't often get sick. Right? They host Ebola and they don't get sick. Coronaviruses and they don't get sick. Flu viruses and they don't get sick. There's a weird fungal infection that seems to be getting them, but other than that, they are really good at fighting off infection. And the scary thing, I guess, for me, when I think about it is, picture the part of the world where you normally have Ebola infections or Marburg infections, sub-Saharan Africa. The range of the fruit bat actually extends throughout India, Southeast Asia, and into Australia. So why we don't have Ebola in those places, who knows? Okay. The most recent outbreak that was kind of a major outbreak was in 2014, 2015. There were 11,000 or so deaths, but there were actually a lot more infections. And so the mortality rate ended up being closer to, I want to say 30% in this particular outbreak. Part of that is because with every outbreak, groups start to work on treatments, because if this does take hold in a population, it can be very, very dangerous. And so what some companies have come up with are basically artificial antibodies. So artificial antibodies would be given once you've been exposed. They're preformed antibodies that were made in a lab that are specific for Ebola virus and can neutralize the virus and prevent major symptoms from developing. You can use general antivirals like interferon to help boost the immune system, nucleoside analogs. And the other thing you can do that involves antibodies is if you have a patient that has recovered, you can use their serum, their antibodies, to treat other patients. And so during this past outbreak, 8-9 years ago, there was a patient who came to the US. I believe he arrived in Dallas. I know it was Dallas, but I believe he arrived from Liberia. And he went to one of the hospitals in Dallas and said, I don't feel well. And they sent him home. And then a few days later, he came back with all of the classic symptoms of Ebola. And so, of course, the hospital in Dallas lost their minds because they have this active Ebola patient in their ER. And he did end up dying of the infection. He infected 2 nurses, one of whom got on a plane and was going to Chicago to be in like her sister's wedding or something, or to try on bridesmaids' dresses. So it was a lot of like maneuvering with the public health system. But there was an American doctor working in Africa who, when he got Ebola, they evacuated him back and he recovered. And so they took his serum and they treated a handful of other American healthcare workers who were evacuated from Africa back to the US. So his antibodies were used to help reduce the symptoms and to potentially save those patients. One of the challenges is, and the reason that Dallas was really freaking out, is that Dallas does not have a biosafety level 4 facility for treating patients. So Ebola, Marburg, some of the other viral hemorrhagic fevers, Crimean Congo, Lassa, are biosafety level 4, meaning they have very, very high mortality, no preventatives, very low treatment options. And so there are only a handful of facilities in the US that are equipped to take care of patients who have a biosafety level 4 infection. Dallas was not one of those places. So they, really freaked out because they didn't have the infrastructure for it. When the Americans were coming back, one of the facilities is in Nebraska. So they had them come back to Nebraska. Okay, so this is one that if this is what you suspect, do not touch, call the CDC right away, isolate and quarantine anyone who may have come into contact with the patient or the patient's fluids, because the fluids are going to be contagious.
If you had like antibodies from the strain that doesn't kill people, could that help with like the other strains?
Don't know. They haven't tried that. So that one that doesn't kill people, they call it Ebola Reston. Reston is a city in Virginia, and so they call it that because that's where they found it, was in Virginia. And so of course there was cool, we have Ebola in Virginia. This is fine. There's a whole book about it called The Hot Zone, if you've ever heard of the book The Hot Zone. And they made a TV show about it.
The second person told me that I should read that book.
You should read the book, or they did a mini series. Maybe National Geographic did it. I watched it on Hulu, and they did one season on Ebola, The Hot Zone. I don't remember what they did the other season on. They were both good though. So anyway, if you don't like to read, if you'd rather watch TV, you can.
Is there like any phase where it's like too late to get any like sort of treatment?
Well, I mean, you can try to save somebody once they're bleeding out of everywhere, but that can be very challenging. Yeah, once you have the vasculature leakage and you're having so much internal bleeding, that can be really tricky to stop. Other filovirus questions? I have flu-like symptoms. Let's see, is this the flu?
Every time I have flu-like symptoms.
I mean, that's like when I wake up with a stiff neck. Well, am I going to die? Do I have meningitis, or am I just old? Maybe both. Why not both? Okay. Other questions about filoviruses? Okay. So the next group of viruses, or family of viruses, are the REoviruses. REO is an acronym, respiratory, enteric, and orphan. I don't know who comes up with this stuff. That's fine. So the really unique thing about these, actually there's two unique things, and we're seeing them right now on the screen. One, they have a double capsid. So they have 2 protein layers protecting their nucleic acid. So I want you to think about the implications of trying to clear one of these infections using disinfectants, how long it might persist on a surface, what parts of the body it might transit through. 2, it has a double-stranded RNA genome. So we have only talked about RNA viruses before as either being positive sense strand or a negative sense strand. This one is double-stranded, so it has one strand that could immediately be translated into proteins, and it has the other strand that can serve as the template for the synthesis of more RNA. So it has 2. Not entirely unique, it does also have a segmented genome. Which other virus did we talk about that has the segmented genome? Flu, right? The orthomyxoviruses. Influenza has a segmented genome. Okay. So what happens that's a little bit unique when REoviruses get into the host cell is they don't open up and dump out their genetic material into the cytoplasm like other viruses do. Instead, they just kind of crack it open a little bit and try to protect their genetic material as much as possible. And the reason for that is that our cells never make double-stranded RNA. Okay, a couple exceptions. But the exceptions, when we make double-stranded RNA, it is always so that that RNA will be destroyed. Our cells destroy double-stranded RNA. We use it as a gene silencing mechanism in our cells, or a system to remove transcripts. So when our cells see double-stranded RNA, we think, oh, that should probably be destroyed. So by kind of hiding, it's like this, right? It's like, ooh, 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 I've got my RNA over here. You can't see it. By hiding the RNA just a little bit from the toll-like receptors and other machinery inside of the host cell, it's trying to protect the genetic material from being destroyed. So that's a little bit unique among RNA viral replication. Okay. So the only REovirus we're going to talk about is Rotavirus. And we talk about rotavirus because especially those of you who might be interested in pediatrics, rotavirus is one of the most common causes of infant diarrhea worldwide. As you might imagine, because it is a double capsid, it is not enveloped, right? It's a double naked virus. It is very stable to the environment, including detergents, pH, freeze thaw. And in fact, what happens is once it gets into the GI tract, some of the enzymes that we use to digest our food enhance the infectivity, allow it to more readily get into host cells. It's almost like our digestive enzymes like pre-process the virus for us so it can get right into our host cells. And so again, rotavirus survives the stomach, particularly after a meal. Rotavirus is often associated with contaminated food and water, which remember, if you eat something, that can temporarily raise the pH of your stomach, allowing more things to survive. But its double capsid also helps it to be a lot less pH sensitive. 8 hours after infection, you would have detectable viral protein or RNA in cytoplasmic inclusions. So theoretically, you could see it under a microscope. And a lot like norovirus, you shed a lot of viral particles. So during an active infection, your patient is going to be shedding upwards of 10 to the 10th virions per gram of stool. So it's a lot. Yes?
So, for example, if the pH level goes up, it's going to cause more problems with the stomach?
No, I mean, in patients who just overall have a slightly less acidic stomach acid, that's actually really highly associated with bad breath. Like people who have chronic bad breath, sometimes it turns out they have issues with their stomach acid, so they're not digesting and getting rid of the food as quickly as they should be. So it's kind of like, as gross as it sounds, it's like rotting in there and the smell comes out your mouth. So people who have chronic bad breath or halitosis, sometimes it's a stomach acid thing. So if you take drugs that like if you have a lot of acid reflux and you take drugs to help reduce the acid reflux, sometimes the side effect is bad breath. I mean, bad breath can be caused by other things too, like poor oral hygiene or tonsil stones, but you know.
But I personally know someone who had stomach acidity problem.
Mm-hmm.
It's causing the bad breath problem.
Yeah.
Yeah.
Mm-hmm. I mean, and I'm sure it doesn't, it doesn't smell good for the people who are smelling it, and I'm sure it doesn't taste good for that person either. Like, when you have bad breath, and you're like, oh, the coffee, or should have brushed my teeth, or, garlic, whatever you ate or drank that, made your breath stinky, like, So one of the cytopathic effects caused by the virus is that in some of those cells lining, I don't know why that happened, the cells lining the intestinal tract, right? They have those microvilli that help increase the surface area for